Hi guys, welcome to your Chapter 5, Lesson 6 notes on parallel and perpendicular lines. Remember that parallel means they have like this and they never touch. Fun fact, if you are in Notability and you duplicate, they will always be parallel, unless they're the same line. But yes, they will always be parallel, so that's super fun. And then perpendicular means they are at a right angle, like that. Okay. By the end of the day, you will be able to determine whether lines are parallel, whether lines are perpendicular, or whether they're just like straight up not either one of those things. And you'll also be able to write equations of parallel lines and of perpendicular lines. So let's get started. So if we have our two friends, Frank and John, we know that they run at the same speed. If Frank starts running a race, so we've got Frank, here he goes, just to help, let's make him purple, and we'll make John, whatever that is. So Frank starts running a race, and then John starts running the same race 10 seconds later. They're moving at the same speed. So when will John catch up with Frank? He won't. Trick question. The answer to this is never, because two things moving at the same rate will never touch. And that brings us to our definition of parallel lines. Parallel lines never touch because they move at the same rate. But what that means in like graph language, if they're moving at the same rate, that's the same slope. So two lines are parallel if they have the same slope. Here we've got two lines down here. We've got y equals 1/2 x plus 1. And we've got y equals 1/2 x minus 2. They're moving at the same rate. They have the same rise for the same run. They've got 1/2 as their slope. So they will never touch. But you'll notice they have different y-intercepts. This is because they are unique lines. If they had the same y-intercept, they would be the same line, so then they wouldn't be parallel because they're the same line. So, yay. So it's worth noting that while they have the same slope, they have different y-intercepts as well. So that's exciting. But the key idea here, parallel means same slope. That's your key idea. Know it, love it, remember it. And by the way, all horizontal lines, remember that horizontal runs side to side, they have a slope 0, which means all horizontal lines are parallel to each other. Isn't that so fun? So that's a fun fact. Similarly, vertical lines all have a slope that's undefined. So they are actually all parallel to each other as well. So tell your friends. That's a cool fun fact. Okay, so since parallel means same slope, we want to write in the equation of a line that's parallel to this line. So how we're going to do it is we know, you know what? We know our slope needs to be 2/3 because it needs to be the same as this other line. So it's 2/3. And whenever we know the point that it passes through 12, 5, we know a point, we know its slope. So let's use point slope form, shall we? Remember that point slope form is y minus y1 equals m times x minus x1. So we're going to take our point and plug that in. We're going to take our slope and plug that in as well. That gives us y minus our y coordinate here is 12. So y minus 12 equals our slope is positive 2/3 times x minus our, oh shoot, I totally highlighted these wrong. You guys, I played myself. Y is green, x is yellow. So it's y minus 5 equals 2/3 x minus 12. That's the equation of our line. We could be done, because that is the equation of a line, yay, except it asked for slope-intercept form. Remember that slope-intercept form says y equals mx plus b. So that's fun. We can just solve for y if we want. So we have y minus 5 equals 2/3 x minus 2/3 times 12, which is 2/3 x minus 2/3 of 12 is 9. So that's exciting. Just kidding, it's 8. It's 8. Man, I'm on a roll today. And if we want to get y by itself, we need to add 5 to both sides, giving us y equals 2/3 x minus 3. We've got our slope-intercept form, because our slope is 2/3, our intercept is -3. We've got it. There's our slope-intercept form. Now, was that the only way to find slope-intercept form? It wasn't, but that's my favorite way. I think it's the easiest, but that's just because of the way I think. Okay, so remember, parallel means same slope. The slope is the same. Perpendicular means the slope is not going to be the same, but it's going to be a special different. Perpendicular lines intersect at 90 degrees. They give us a right angle. Perpendicular. There we go. So they intersect at right angles, which is 90 degrees. Now, in order to be perpendicular, you need to have two things happen to your slope. First, you see how this slope is a -2. This one is a positive 1/2. So they need to first be opposites. They need to be opposite, which means one is negative and one is positive. And you need to flip them around. See how we start with 2 and then we end up with 1/2? You need to take one number, if it's, it's a fraction like that, you need to flip him upside down to get that. So you need to invert your fraction. We call that a reciprocal, because there's some reciprocity there. The reciprocals, flip it upside down. Reciprocal. Just like that. Another way to think of a reciprocal is if you have m, then its reciprocal is 1 divided by m, because that's how you flip it around. So that's exciting. The reason I use m is because m is our slope. So if you have a line with slope m, then its negative flippy is its opposite reciprocal, -1/m. So that's how you find the slope of a perpendicular line. You flip it and you make it negative. So if that's helpful, you can write that down. You flip it and make it negative. Cool. So now let's look at these guys. And we're going to say, are they parallel, perpendicular, or are they neither? Well, how do we know? We look at their slope. So it's a question of slopes. So the easiest way to compare slope is to get them both in y-intercept form. This guy right here already is, we know his slope is 4/5. So we're going to take our other guy right here, 4y equals -5x plus 12. And we're going to get him in y-intercept form by getting y all by itself. We've got this 4 times y. So we're going to divide everything by 4 to get rid of that. On this side, they cancel out, which is super nice. It's the whole reason why we did it. Then we get -5 divided by 4 times x plus 12 divided by 4, which is 3. So this guy is actually just -5/4 x plus 3. Okay, now we can look at his slope. His slope is -5/4. Now remember, they're definitely not parallel. Parallel means same slope. And these are not the same, so it's definitely not parallel. But is it perpendicular? Well, how do we tell? You gotta flip it and make it negative. So we just gotta figure out, does the slope have an attitude adjustment? Did he flip out? That is, did he flip out and is suddenly super negative all the time? Well, let's see. Hey, look, that's the same thing. So yes, they are in fact perpendicular. Because remember, to be perpendicular means you start with a slope m he flips out and is now negative all the time. So if you have one of those friends who like needs an attitude adjustment or something, it might just be that they are now perpendicular. Okay, well anyway, taking this information with our slope, how are we going to write the equation of a line that's perpendicular? Well, what do we know? We've got our point. We can figure out what our slope needs to be, and then let's put it in point slope form. So if we take what our slope needs to be, here we go. Let's start out with 1/3. That's our original slope. Our original slope is 1/3, and now we need to flip out and be negative. -3/1 is the same thing as -3, so that's the slope we want. We want a slope of -3 that passes through 2, 4. So I'm just going to go straight up use my point slope form again, and because I'm not lazy, rather I am energy efficient, here comes this guy. Down here, excellent. My y1 value is 4. I shouldn't have done that. There we go. My y1 value here is 4, so I'm going to place my y1 with 4. My x2 value here is 2, and by x2 I mean x1 value is 2. And finally, the slope that we want is a -3. There we have it. Y minus 4 equals -3 x minus 2. Is that great? There we go. Also, a way to check that you got your slope right is your slopes should multiply in perpendicular lines. Their slopes multiply to -1. That's a fun hint that I forgot to tell you earlier. So in perpendicular lines, their slopes multiply to -1. Let's check to see if we did this right. Here, our slope is -3. And here, our slope is 1/3. So -3 times 1/3, well, that's the same as -3/1. We multiply across. We multiply across to get -3 over 1 times 3 is 3. -3 divided by 3 is -1. Yeah, we did it. Let's add that to our cheat sheet somewhere. Where was our, where do we put our key lines? All right, here. Their slopes multiply to -1. That's a good key idea to remember. Okay, that's great, but when are we going to use this in real life? Well, let me tell you. Let's say you're building a house, or you're building a ceiling, or you're building a playhouse for your children in your backyard, and you are now an architect. And you're going to design the ceiling of a room. You need to, in your AutoCAD design program, you need to write an equation to represent your new beam. And your new beam is going to be perpendicular to the ceiling. So it's going to be like that, kind of. Okay, be perpendicular to the existing beam, which is your red line here. The new beam will pass through the corner at point A. What's an equation that represents the new beam? Okay, so what's the equation of this line? Well, what do we need to write the equation of the line? We need a point that it passes through, and we need a slope. Well, we know the point that it passes through. It's A. What's the coordinates of A? Well, how far over is A? A is at 12. It's going to go over 12 up 10. Okay, so the coordinates of our point are 12, 10. That's really nice. So we know our point is already 12, 10. Excellent. 12 being how far over we went, 10 being how far up we went. Well, that was nice. But what do we need our slope to be? In order to figure out what slope we need to figure out what slope is going to be perpendicular to this line. Well, what is the slope of this line? We got to figure out. Okay, so the slope that we want, is going to be perpendicular to the slope of the red line, our red slope. Well, our red slope, remember, slope is always rise over run. So let's find our rise here. How far down do we go? Well, we start at 8 and we go, oh, rather, sorry, I'm going to use these 2 points right here, this point and this point. Those are not the only points you could use. Basically, anywhere where they cross is totally fine, but those are the easiest numbers, so I'm going to do these. So our rise here is -8. We go down from 8 all the way to 0, and then we go from 0 all the way over to 12. That's why I picked them, because they are so easy to see. So our rise here is -8, and our run here is 12. So our slope is -8 over 12, but we can reduce that. So it's not 4, they're both divisible by 4, -2/3. So the slope of the red line is -2/3, cool, but we don't want exactly that slope. We want to figure out what is perpendicular, where did I put perpendicular? Perpendicular to this. So how can we find it? Well, remember we just need to take it and flip out, right? So in order to be perpendicular, you need to take your -2/3, and you need to flip out, giving us 3/2. But it needs to not be negative, because we take that attitude adjustment, go from negative to its negative, which is positive. Negative times a negative makes a positive. Boom, that's the big old slope we want, 3/2. Our slope should be 3/2. Ta-da! Okay. So that's the equation of the line. Up 3/2. Let's write that big and fancy. So we have y minus y1 equals m times x minus x1. And there you have it. That is the equation of the line. Again, y minus y1 equals m times x minus x1. That's so good. Nailed it. Let's draw on the graph real quick. I'm going to do a backwards rise over run. What did we say it was? 3/2. So that's a run of 2, a rise of 3. So we go up 3/2, giving us a new point right there. And then boom. Just like that. Haha, perpendicular. Cool. Hey, that's everything. To just sum everything up real quick, parallel lines means they never touch, and their slope is the same. For example, you could have y equals 4x minus 8, and y equals 4x plus, I don't know, 13,000. Great. As long as their slopes are the same, they are parallel. Perpendicular lines, on the other hand, means they intersect, they do touch, they intersect at a 90-degree angle. That means that their slopes are m and -1 over m, also known as opposite reciprocals. And by the way, if you take them together, if you take the first slope and you multiply it by the second slope, you get -1. So that's exciting. For example, if you have the line y equals 5x plus 2 and y equals -1/5 x up plus 2, they can be the same. Their y-intercepts don't have to be the same, so let's make it 3. 5 times -1/5 is -1. Boom. So good. So you have it. I hope you have a wonderful time on your homework.